right. Everybody doing good today? Enjoying Melbourne? Awesome. Go ahead and grab a seat. We'll go ahead and jump in. My name is Kyle Winters. I am a technical advocate with the Cisco Learning and Certifications team. I take a focus on security. I've had many different roles over the years, whether it's solutions architect, technical marketing, business development, and I'm here today to talk to you all about eBPF. One quick note for you all, there is a little volume knob on your headphones. So if you feel like the volume is not loud enough or too loud, it's on the bottom side of one of those headphones there. Feel free to adjust it as you need. But let's go ahead and jump into things. So a quick agenda. I'm going to give you all an overview of what eBPF is. And then we'll go right into some examples, show you some hands-on exercises where we're doing things like tracing system calls with eBPF and monitoring network traffic, as well as being able to do packet filtering with eBPF as well. We'll then close it out by talking about how eBPF relates to Cisco and some of Cisco's technologies that are leveraging eBPF as well. So to begin, what is eBPF? And to start there, we need to start by understanding the kernel space. So many of us are familiar with operating inside of the user space. That can be the applications that we're constantly using, whether it's a web browser or even the Linux terminal as an example. Everything that you're interacting with directly typically is in the user space. There's also this physical hardware as well too, and that makes up network cards, memory, storage, and as I'm sure you're aware, there's a ton of different vendors out there that exist for all of these different parts of the physical space. So for the user space to be able to communicate with the physical hardware, that can be really complex on a direct level. So many different vendors have so many different ways that they need to be able to communicate and be able to achieve the functionality that you're trying to go after. And that's where the kernel space comes in. It sits in between that user space and the physical hardware and allows you to have a normalized way for the user space and the applications that are running inside of it to communicate with the physical space. So what if you need to customize your kernel though? That can be a very tricky task. If you're trying to edit the kernel code on your own, it's not advised. It can be very complex and difficult to do. And that's where eBPF comes in. So eBPF originated from the Berkeley Packet Filter, and early on it stood for Extended Berkeley Packet Filter, but that name got dropped and it's now just referred to as eBPF because it can do so much more than just packet filtering. It's really easy to use. The eBPF code that I'll show you today is largely written in C. It's a restricted version of the C programming language, but it's really easy to use. It allows for dynamic changes, so you can deploy eBPF modules on the Linux kernel without having to reboot your system and restart it. It has performance advantages as well because it is running in that kernel space. You're able to do certain things before it even makes it to the user space. And it also has security built into it as well. So there are certain types of runtime validation that's occurring on it. It's very secure to do. And because it's using that restricted version of the C programming language, it eliminates some of the possibilities for malicious behavior. So just to give you some basic concepts of eBPF as well, and just really quick, there's a lot of different use cases for eBPF as well. I want to talk to you today about some of the security use cases, but it goes beyond that. We'll touch up on networking as well. There's observability use cases for it too, but it's a very powerful and robust tool to have in your tool set. So some basic eBPF concepts to get you started. There's the eBPF hook, and this is typically triggered by some kind of process or system call. When that system call is evoked, the eBPF hook is triggered in a sense. And what happens when the eBPF hook is triggered, there'll be some kind of helper call that is then performed inside of the Linux kernel. And it can do a lot of different things, you know, depending on what the system call is, whether it's, let's say, the creation of a file, some kind of network connection that occurs. These things can trigger different types of functions. And some of it may just be as simple as modifying key value pairs in a table. And some of it can be even more complex, like filtering out different types of traffic or whatever you can get creative on ultimately. One thing I just mentioned, key value pairs, that's the concept of an eBPF map. And it's essentially a storage of data. It's stored as binary blobs in memory in the kernel. And this allows you to have essentially a key value pairing associated with whatever system or whatever process you're running eBPF wise, and be able to reference that as well in the user space if you need to as well. So this is a great way to store data and be able to call it later on. And we're going to use some of this as an example coming up here as well too. When it comes to security, there are a lot of different use cases for eBPF. We'll talk today about advanced packet filtering and processing, but it can do so much more. DDoS mitigation, intrusion detection and prevention, runtime security enforcement, sandboxing. There's a ton of different capabilities that it can do. So it's an incredibly powerful tool, and we're continuously building on those capabilities on a regular basis. So there's a lot more coming out across the board as well. And just to kind of give you some principles of eBPF based security, really, I think the top line right here, in kernel filtering is essential for low overhead and correctness. So being able to filter data or network traffic or whatever it may be in the kernel allows it to be very quick and effective, and allows it to essentially find potential vulnerabilities or weak points or malicious traffic before it even makes it into that user space. That's one of the principles of it. Another one is that, keep in mind, eBPF is more than just system calls. So many people think, it's just Linux system calls, things like file directories, but it could just be also things like file access, any type of operating system functions like worker threads or schedules, things like cron jobs, security things as well, like namespaces, changes to groups and accounts, and of course, networking. So we'll take a look at some of the networking stuff related to it as well. But just overall, I think a common principle for eBPF security is that it's really about enforcement of policies that are stronger than being reactive. And when things are essentially being processed from a security perspective in the user space, that's very reactive because it's already traversed through the physical hardware, the kernel space, and now it's interacting in that user space. And that's a very reactive approach. Whereas enforcing it through the kernel and leveraging eBPF allows you to be a lot more proactive and identify the potential malicious traffic or behavior before it even makes it into the user space. So it's shifting your security even further down the tech stack into the kernel space. So let's jump right in. I'm gonna take a sip of water really quick. And let's go through some examples. And I'm going to talk really first about kind of some of the examples that we're going to do, and then I'm going to dive into a lab environment and show you all. But the first thing that we're going to do is trace system calls in eBPF. And we're going to use a tool called BPF Compiler Collection, or BCC. It's a very lightweight toolkit of efficient Linux kernel tracing and system manipulation functionality. It's essentially very easy to install on any Linux operating system. It's leveraging Python and C to perform a lot of the functions, and we're going to run into some Python and C code here shortly. But BCC isn't the only one. It's great for beginners to get started with eBPF. But there's other different types of libraries and tools that you can use as well. One that I want to make a quick mention of is Selenium. It's eBPF networking, observability, and security, put together by Isovalent, a recent acquisition of Cisco. And it's a great toolkit that has a lot of pre-built functionality. Consider it like a marketplace of eBPF capabilities almost. So I definitely recommend you check that out as you continue your eBPF journey. But let's go ahead and jump into some sample code about how to trace system calls with eBPF. And one thing I want to note as well is that this example and the next one that I'm going to show you, these are all available on Cisco U for free. It's a free tutorial on there, both of these, and you can take these tutorials at any time later on if you want to follow along with what we've covered here today. But we're going to start by tracing system calls with eBPF. You can see some Python written here, and first thing to note is that we're importing BCC as a Python library there. And then right here is actually our BPF program. So this is C code as a string inside of this Python file. And this is essentially going to print to standard out anytime a new directory is created in our environment. So this is a great example to kind of show you some of the capabilities that you can do to log and monitor different types of traffic, or not traffic necessarily, but activity that's occurring on an operating system. So we have our BPFC program there. This is where we're actually loading it and running it. And this while loop down here is the event loop that's going to continuously run until we kill the program. That's going to then print that data to standard out here. So this is one of the examples that we're going to run shortly here. And actually, maybe I'll just go ahead and run it now, actually. Let me go ahead and jump over there. And can you all see this okay in the back there? Cool. So I am on an Ubuntu host here, and I'm just going to go ahead and pull up my program so you can all see it here. eBPF trace calls. Let's just take a look at it really quick. It's that same exact code that we saw there before. And I'm just going to go ahead and run this. So sudo python 3 eBPF trace calls.py. Go ahead and enter my password there. All right, so that's running. So now over here in this other terminal that's connected to the same host, I'm just going to go ahead and create a directory. Let's just call it Cisco Live. And you can see that the eBPF program captured that and wrote that to standard out there like that. So a great way to do essentially logging of different types of operating system activities that can occur on an operating system leveraging eBPF. A little bonus that I want to show you all as well too is being able to monitor network traffic using eBPF. So with BCC, there's a ton of capabilities that are built in, and you can run these programs at any time. If I come in here and say sudo user sbin, and let's do TCP connect BP-BPFCC. I'm going to go ahead and run this program here. And now if I make any kind of TCP connection from this host, it's going to log and monitor that as well too. So I'm going to go ahead and say wget google.com. And just a quick note, this host isn't actually connected to the internet, so it's not going to resolve, but you are going to see those DNS attempts that occurred. The attempts to try to get that information there on the left actually looks like it's rather, yeah, those connections there. So you can monitor this traffic using eBPF as well too. There's a ton of capabilities in here. If you come over on the left and just say ls-al user sbin BPFCC, you'll see there's a ton of different stuff that BCC has installed on here that you can leverage. Some of it's like system mounts, file counts, all these different things. They're really a valuable tool for you to play with and get started on your eBPF journey. So let's go ahead and jump back over to our slides now. And let's go into another example. Oh, let me jump ahead here. Let's go into packet filtering with eBPF. So I have two Linux hosts. The first one is on the left there. That's going to be our source. The next one's on the right here. That's going to be our target .130 versus .131. And we're going to try to make different types of connections between those two hosts. We're going to try an SSH connection as well as a ping using ICMP. And when we run the eBPF program, you're going to notice that these connections are no longer going to work. So we're going to try it first without the eBPF program running, and then we're going to go ahead and run it, and you'll see that those connections will be denied. It'll essentially hang, and there will be no connection that's made. So how is it actually going to do this? So on the target host where we're going to run the eBPF program, we're going to read in the packets that are coming into this host. And we're going to take a look at the IP header and the TCP UDP header. We're going to extract that information and put it into a data structure that looks kind of like this here. So we're going to essentially have the source IP, destination IP, port for the source and port for the destination, as well as the protocol that's used. And we're going to store that in memory. And we're going to have an eBPF map over here that's going to have the types of connections and patterns that we want to discard that traffic on. So if any of the packets that are coming in from this host match this connection or this data structure here, then we're going to discard those packets. And take a look at the program and how we're going to do that. This is a bit of the C that's running the eBPF program here. A couple of pieces of it. This is where we're importing the C libraries that are necessary to read in information, such as the IP, TCP, ICMP connections. And here's where we create our data structure as well. So you can see the source IP, destination IP, the ports, and the protocols there. Those are all being stored as integers for us to put into our eBPF map. We then create the eBPF hash map right there. And this is where that filtering logic is done. So it's looking up to see if anything matches that hash map that we've created, that connection that we want to decline. If it matches that, then we're going to discard that packet. And to take a look kind of where this fits into the actual Python program, you can kind of see it gets called up a little bit there. That's stored as a string and it gets imported right up there into the BPF program. And a couple pieces to note if you are going to follow along in this tutorial later on. For this particular file, you need to specify a couple pieces of information, such as the interface that you're leveraging. You can just put it in there. Right now, mine is looking something like that, I believe, as well as the IP address of the host that you want to block out. You can obviously get more complex as you become more advanced with eBPF and be able to make it a bit more dynamic based off of your network environment. But for a simple example, we're just going to leverage the IP address and the interface that we want to monitor that traffic on. So let's go ahead and jump right in. I'll show you all how this is done. So let's jump back over here, just clear this out a little bit. So you can see we have our two hosts. On the left is Ubuntu 1, and you can see the IP address of this one is that 130 there. And on this side here, it's that 131. Take note of our interface name here as well too, and let's just make sure that that is populated into our eBPF program here. So it's this one I have here, eBPF-packet-filter.py. And you can see there's our IP address of the host that we want to block out there. And we're saying specifically that we want to block out TCP connections on a specific port or any TCP connection, as well as ICMP connections down below. And if we scroll up, I believe we should have the interface name right here. So everything looks like it's configured correctly. And let's just go ahead and test this out. So let's see, before we run the program, let's go ahead and ping this host on the right, 192.168.9.131. And you'll see that those pings are going through, just like what we would expect. Let's just go ahead and test an SSH connection as well. Let's SSH Kyle at 192.168.9.131. Put in my password, and you can see we've SSH successfully. Now let's go ahead and exit out of here, and let's go ahead and run our eBPF program. So we're going to say sudo python 3 eBPF-packet-filter, and let's put in the password for the admin permissions, and that is running. So now if we go back to our first host, that's our source, and we run that ping again, we shouldn't be able to connect to it at all, and these pings should essentially time out. So if we go ahead and run this, you notice before those pings were returning back. Now it just seems to be hanging. So what's happening is this eBPF program on the right recognizes that this host, this 130 host on the left, is sending ICMP messages, and it is filtering those out. Let's go ahead and try with a TCP connection now. So let's go ahead and just to confirm there, you can see 21 packets transmitted, 0 received, 100% packet loss. So that packet filtering is indeed working properly. Let's go ahead and try that SSH now, and I'm just going to tab up. So we have our SSH command there. And you can see it's not even creating that connection. It's not even prompting me for the password. It's discarding those packets before it even gets to that point. So it's once again recognizing the ports, the protocols that are used, and the host that's trying to communicate with, and it's filtering it out right on the kernel level, so it doesn't even make it to that user space as well. If we go ahead and kill this, and we kill our eBPF program on this side here, we want to try that SSH again. As you can see, all of a sudden it magically is working. And we can SSH back in. And if we want to try that ping again one more time, you'll see that that is also working now again too. So that's just a simple example of some of the stuff that you can do with eBPF. Again, this is all available on Cisco U as a free tutorial. So I definitely recommend, if this is something that interests you, that you follow along with those tutorials later on your own as well too. So why is Cisco talking about eBPF to begin with? Why do we feel like this is such an important technology to share with you all? Well, for one, it is an incredible technology that has a lot of value and use cases associated with it. Thanks to our recent acquisition of Isovalent, we brought in a lot of eBPF capability and some of the brightest minds in eBPF as well. You may be familiar with Selenium. I mentioned that earlier. It's a great tool for things like observability, networking, and security. But there's also other tools like Hubble as an example that Isovalent has put out. That's great for network observability. And one that I'll quickly touch up on a little bit more is Tetragon. And that's really about security and runtime enforcement, leveraging eBPF as well. So you can do things like find security incidents related to process execution events, system call activity, input and output activity related to networks and file access. It's running on the kernel on your containers and leveraging eBPF technology to enforce security essentially at runtime and in the kernel space. So it's a great and powerful tool that's been put together. Another tool that Cisco is putting out very soon that's going to be leveraging eBPF as well is Hypershield. So you may have heard some buzz about Hypershield. There's going to be a lot more information coming out on that in the near future here. But it's really a new approach to building an AI-driven data center that's leveraging eBPF across the board for a lot of its capabilities. So using these essentially Hypershield, we want to be able to help you kind of assist in driving your data center infrastructure design and implementation, augment it however you need, and automate a lot of the steps along the way. So there'll be a lot more information coming out on Hypershield in the near future. It's an exciting application of the eBPF technology as well. So hopefully this was a valuable and informational session for you. Like I mentioned, there's a lot of resources out there on eBPF. You can go to ebpf.io to learn a lot from the folks there who put that together. We do have free tutorials, like I mentioned, available on Cisco U. That's u.cisco.com. And Isovalent also offers some interactive labs that you can leverage as well, too, and some additional readings. So there's a lot of great resources available to you to skill up when it comes to eBPF. Like I mentioned, Cisco U, if you're not familiar with it, it is a very powerful tool to kind of address the skills gap that exists in the market today. There's a ton of different learning paths, whether it's for certifications or learning a specific technology. There's free access available to all of you, to anybody who's watching as well too. If you go to u.cisco.com, you can sign up for some free tutorials that are available for you on there as well. So I highly recommend that you check that out. It's a great resource. And just a couple other things to note before we call it a wrap here. There are some keynote deep dives that are occurring later this week, so check those out on Wednesday. And if you don't mind completing your session surveys, that's always appreciated. Your feedback is always great to hear. And if you complete 4 session surveys, you get a nice t-shirt. So who doesn't like more swag? So I encourage you all to fill those out. And while you're here, check out some of the things. We have demos of Cisco U on the side over here. The DevNet Zone's a great resource. Capture the flag activities. There's a ton of stuff to do. We have 50% off certification exams as well during the event this week. So feel free to take a certification exam if you'd like as well too. But thank you all for joining today. If you have any additional questions, I'll be standing over here. But I appreciate all of your time and look forward to hearing about your eBPF adventures. Thank you.